Okay, welcome back to the 2023 Algebra 2 Final Exam Review. In this video, we're going to look at Section 5, where we analyze the discriminant of quadratics and determine the number and type of solutions that we have. So a little bit of back information on this. If we look at the quadratic formula again, we have x is equal to negative b plus or minus the square root of b squared minus 4ac, and that's all over 2a. And there's three types of solutions that we get with this. So I'm going to make all of these parabolas opening upwards. But the first type that we see, this is the x-axis, we have parabolas that can intersect our x-axis in two distinct points. And we would say that this has two real solutions. The second type is when we have a parabola that intersects the x-axis at a single point, and we say that it has one real solution. The third type of solution that we see is when a parabola doesn't touch the x-axis at all. And visually, we would say that it has no real solutions because it doesn't intersect the x-axis. But as we've seen throughout this course, or at least in the last few videos, that we have imaginary solutions where we introduce this I. Remember, I is the square root of negative 1. And so when we saw solutions like this, when we got something like, I don't know, 2 plus or minus 3i, these are actually called imaginary solutions because they have this I in here. And so this plus or minus really means that we have 2 plus 3i or 2 minus 3i. And this one, we would say that it has two imaginary solutions. And so sometimes when we're solving quadratics, or maybe for some application that we need, we don't actually care what the solutions are for our quadratics. Maybe we only care about the qualitative properties of our quadratic, and maybe not so much the quantitative ones. So the quantitative properties would be something like the actual solutions, whereas the qualitative properties would be something just like this, where we only want some properties of our solutions, but we don't necessarily care what they are. And so we can achieve that without actually going through and solving for what our solutions are and figuring out, do we have two real? Do we have one? Do we have two imaginary? We actually only need to analyze the discriminant here. So again, this is called the discriminant. And depending on the value of the discriminant, it will tell us what kind of solutions we have. So for two real solutions, that is when we'll call our discriminant D. So when our discriminant is greater than 0, aka when it's a positive number, we have two real solutions. When our discriminant is equal to 0, probably don't need to write 0 in words there, but when our discriminant is equal to 0, we have one real solution. And for no real solutions, this is when our discriminant is less than 0, aka when it's a negative number. So if we can just calculate our discriminant here, we can figure out the type of solutions that we see without actually figuring out what those solutions are. So it's less work for us. If we only care about answering the question of what type of solutions we have, we could, of course, go through the whole quadratic formula, but it's going to be more work than is necessary. So let's look at number 49 now. So for number 49, we have 4r squared plus 8r plus 4 is equal to 0. And so, remember that our discriminant is equal to b squared minus 4ac. And so, we need to figure out what a, b, and c are. We have a, b, and c. Remember, this is when our quadratic is in standard form. Ax squared plus bx plus c is equal to 0. So, a, b, and c. And we see here that a is equal to 4, b is equal to 8, and c is equal to 4. So, our discriminant being this, I'll just rewrite that down there. If we plug in b squared, we get 8 squared minus 4 times a, which is 4, times c, which is 4. And if you have a calculator available to you, it may be quicker to just do this in your calculator. But if you calculate this out, this will be 0. And so, this tells us that we have one real solution. So without actually solving for what that solution is, we can say that this has one real solution if that's all the information we really cared to find. And again, that's determined by the value of our discriminant. So let's look at number 50. So number 50, we have negative 2n squared minus 8n minus 8 is equal to 0. And so we identify what a, b, and c are. So here we see that a is equal to negative 2, b is equal to negative 8, and c is equal to negative 8. Our discriminant is given by b squared minus 4ac. And when we plug in these values, we have negative 8 squared. Be sure, if you're putting this into your calculator, to put parentheses around negative 8. So something to point out here is that negative 8 squared is not equal to negative 8 squared. If you put this into your calculator, it interprets it as negative whatever 8 squared is, which is 64. But we know that when we square a negative number, negative 8 times negative 8, this would be equal to positive 64. So your parentheses definitely matter here, and that's why it's pretty important to put these parentheses around your b squared. You will get the wrong answer if you don't put the parentheses. And even if you mostly typed it in right, and then all you did was neglect the parentheses, and you may interpret your discriminant correctly with your incorrect value, these parentheses will absolutely change your answer. So we got to be careful with that. But we have our negative 8 squared minus 4 times a, which is negative 2, times c, which is negative 8. And calculating this out, this is also equal to 0. So, another one real solution. For number 51, we have 6b squared minus b plus 1 is equal to 0. We identify what our a, b, and c are. Remember, we have an implicit 1 here when we only have a variable present. And so our a is 6, our b is negative 1, and our c is 1. So our discriminant is going to be given by negative 1 squared, so b squared, minus 4 times a, which is 6, times c, which is 1. And calculating this out, probably in your calculator, is negative 23. And so, looking back at this chart I made over here, we see that if d is a negative number, then we have two imaginary solutions. Or you can write no real solutions. Either one is fine. So we have, I'm going to write two imaginary solutions. But this is our final answer. Number 52, we have 2p squared minus 8p plus 8 is equal to 0. And identifying what a, b, and c are, we have that a is equal to 2, b is equal to negative 8, and c is equal to 8. Plugging into our discriminant, d is equal to negative b squared. So b squared minus 4 times a times c, which is 8. Calculating this out, we get 0. So again, we have one real solution. Let's look at number 53. So for number 53, we have 10b squared plus b minus 3 is equal to 0. Identifying a, b, and c, we have an implicit 1 right here. We have a is equal to 10, b is equal to 1, and c is equal to negative 3. So for our discriminant, we have b squared minus 4 times a times c. And calculating this out, we have 121. So now, again, looking at our chart here, we've seen a case where we have d is equal to 0, which gave us one real. When d is a negative number, we have two imaginary. And now we have our first case on this assignment, where we have two real solutions, where d is a positive number. And so we say that this has two real solutions. Let's look at number 54. Number 54, we have 5a squared minus 9a plus 4 is equal to 0. So we identify a, b, and c. We have a is equal to 5, b is equal to negative 9, and c is equal to 4. Our discriminant is given by b squared, so negative 9 squared, minus 4 times a, which is 5, times c, which is 4. And calculating this out, we get 1. So we have another positive number. Therefore, we have two real solutions. For number 55, we have m squared plus 6m is equal to negative 9. So this one is not in standard form. Remember, standard form is ax squared plus bx plus c is equal to 0. And because this is not equal to 0, we can't analyze the discriminant, not yet. First, we have to make it equal to 0. And the easiest thing we can do here is just add 9 to both sides. And if we do that, we have m squared plus 6m, adding 9 to both sides, plus 9. And then adding 9 on the right-hand side over here will cancel out, and we have this equal to 0 now. Now we can analyze our discriminant by checking what a, b, and c are. So an implicit 1 in front of the m here, and a 6 and a 9, so we have a is equal to 1, b is equal to 6, and c is equal to 9. Our discriminant is given by b squared, so we have 6 squared, minus 4 times a, which is 1, times c, which is 9. And calculating this out, this comes out to 0. So we have one real solution. Okay, and on to 56. For number 56, we have negative 7r squared is equal to 10 minus 5r. So this is again not in standard form. If we want this to be equal to 0 with on the right-hand side, it's usually how we see that. Though there is nothing wrong with adding 7r to both sides. However, what we can do is subtract 10 from both sides and add 5r to both sides. And what we get is negative 7r squared. Erase this. Adding 5r to both sides, subtracting 10 from both sides, and now this is equal to 0. So again, we just subtracted 10, added 5r, and notice that the signs just flip on that. Identify our a, b, and c. We have a is equal to negative 7, b is equal to 5, and c is equal to negative 10. So our discriminant is equal to b squared, so 5 squared, minus 4 times a, which is negative 7, and c, which is negative 10. And if we calculate this out, we get this equal to negative 255. So means our discriminant, the types of solutions we have from our discriminant is 2 imaginary solutions. Let's look at number 57. Number 57, we have 5p squared plus p is equal to 0. So, this is already in standard form. However, notice that we have in front of our squared term, so if I write out standard form real quick, this 5 here corresponds to our a, because it's our variable squared right here. Our linear term, we have an implicit 1 right there, but we're missing a plus c, so our constant term. Anytime you're missing the term, or if you're missing your linear term, doesn't matter which one, you could just write a 0 for that. So we have a is equal to 5, b is equal to 1, and since we're missing that constant term, we don't have that. We just have c is equal to 0. So our discriminant is equal to b squared, so we have 1 squared, minus 4 times a, which is 5, and times c, 0. It's pretty clear that even without a calculator, that this whole term would cancel out because of the 0. And we have 1 left. So since we have a positive number, we have 2 real solutions. Let's look at number 58. So for number 58, we have negative, oops, sorry, that's a v. Negative 8 v squared plus 5 is equal to 3v. Not in standard form, but we can fix that by subtracting 3v from both sides. We have negative 8v squared minus 3v plus 5 is equal to 0. So now we can identify what a, b, and c are. We have a is equal to negative 8, b is equal to negative 3, and c is equal to 5. Plugging into our discriminant, we have d is equal to b squared, so negative 3 squared, minus 4 times a, which is negative 8, times c, which is 5. And calculating that out, we have 169. Positive number, therefore, we have, again, 2 real solutions. Let's look at number 59. So for number 59, we have negative 7a squared minus 8 is equal to negative 6a. Not in standard form, but again, we can fix this by adding 6a to both sides. And when we do that, we have negative 7a squared plus 6a minus 8 is equal to 0. We have a, b, and c. A is equal to negative 7, b is equal to 6, and c is equal to negative 8. Discriminant is b squared, so 6 squared, minus 4 times a, which is negative 7, times c, which is negative 8. And calculating this out, we get negative 188. And so we say that this has 2 imaginary solutions. And last one for this section, we have number 60. We have 2n squared plus 10 is equal to 5n. Not in standard form, but we can fix that by subtracting 5n from both sides. So we have 2n squared minus 5n plus 10 is equal to 0. A, b, and c are given by these. We have a is equal to 2, b is equal to negative 5, and c is equal to 10. And so our discriminant is negative b squared, so negative 5 squared. Sorry, not negative b squared, but b squared minus 4 times a is 2 times c is 10. And calculating that out, we have negative 55, which gives us 2 imaginary solutions. And so that concludes section 5. And I guess that's it for this video. So thank you for watching.